Right? Okay, good. Again, thank you for joining this webinar, UI Development with Trustee Effects on STM32. Here we want you to get started doing great GUIs with Trustee Effects. Before we are actually going to the technical part, let me introduce the team here. Myself, I'm Jørgen Myggen, the business manager of TouchGFX. Behind the scene, we have Søren Mikkelsen, that is taking care of all the technical stuff and also providing the webinars and so making it available for you after the webinar. And now you can actually see Jesper Hedegaard. This is our product manager, a part of our architect team. He will be behind the scene and actually ready to answer chat questions as we go along. So please feel free to put in questions as we go along. And let me introduce Martin. Martin will actually run the seminar, the webinar today. Some of you have maybe seen him on some of the YouTube videos. Here we have Martin. Martin is part of the architect team as well. Have been in TouchGFX, all years. Have great experiences in projects, and he's actually heading the part of the TouchGFX designer. So we have a great team to supporting you. So I will just try to recap. Please put in questions as we go along. This will help us, and it will give answers to your actually needs. Let me just note that the recordings will be made available for you, and you can share them and watch afterwards. From here, I will let Martin take over.
Great. So I hope you can hear me. So welcome from my side as well, and I will try to take you through everything you need to actually get started using TouchGFX on STM32. So a very brief agenda for today is just a very short technical introduction. That's where we use slides. Then we go directly to doing application development. So we'll look at the workflow, and the workflow here means using TouchGFX Designer, our GUI tool, for creating applications, as well as doing C++ code. But we'll get into that in a lot more detail. Then we'll get our application on the evaluation board, in this case the STM32 F769 Disco. Then we'll end off by looking how to actually integrate such a UI with your backend system, with your hardware. So we'll go through a couple of slides highlighting how to do that and actually simulate something that resembles a real hardware backend system. Ultimately, we have questions and answers where we'll do a couple of questions that have come in from you guys, and I think we'll do that as we go along as well. So please feel free to interrupt. I enjoy being interrupted because I listen to myself all the time, so I actually like listening to you. Great. Okay. So what kind of system are we thinking about when we discuss UIs on such embedded hardware? Just to get you a feeling of what is actually graphics on embedded devices. For us, for TouchGFX, it's something like this. So you have a display, of course, that's where you need to show your graphics. But your graphics will typically reside in some part of your chip, or your setup, regularly in some external flash. So this diagram highlights that you will have your graphics in your flash, and your graphics also amounts to things like fonts or characters, what is called glyphs. So everything will be more or less bitmap based and placed in your flash. And then the job of the MCU is really to assemble all the parts needed to make this look alive. So you will take a lot of stuff from the flash, the MCU will do that, and put it into the frame buffer, which resides in RAM, typically internal or external RAM, depending on the amount of frame buffers you need, 1 or 2 or 3. And then this frame buffer, or part of this frame buffer, will be transferred to the display. So that is really the setup of all embedded TouchGFX solutions, you could say. Sometimes the frame buffer is in the display, sometimes it's internal, sometimes the flash is external, sometimes it's internal, external, yeah. So hopefully you get the idea. On the STM32, we of course have a quad spy flash, which is very, very fast and which makes it possible to do really nice graphics even on the 800 by 480 display that is on this discovery board. So we can do quite nice things today, I hope. Great, so TouchGFX, what is it? You could say this no bullshit slides, not it's just the contents. So it's ultimately down below, it's a C++ framework. A little bit of it is a library, a compiler library that you cannot change, or it's very hard to change. And then there's a lot of source code. So that's sort of the core basis of TouchGFX. The reason for having it compiled and not ultimately everything in source code is our protection. So that's our business case, you could say. We have a library, so you need to buy the framework from us, or the solution TouchGFX. Then the C++ framework is targeting a lot of different MCUs from a lot of different vendors. Today we'll look at STM32, and yeah, but that's it down below. Then you get a lot of tools, all the tools that will take all your assets, things like PNG images or TrueType fonts. Even a compiler is included in the tool, so you have everything needed to actually do your application. So you will have, let's say, some PNG images, a couple of fonts, and you specify using our designer, the UI tool, you specify how your screen should look. And then these tools that are included as well will go and analyze your images and spit out C++ code that can then be compiled by any compiler, really. So we support quite a long list of compilers, but at least the main interesting embedded compilers like GCC, Kyle, IAR, and also the accompanying IDEs. Yeah, the designer is, I've already said a bit about it, but that's really our newest addition, but it's getting the main way of doing TouchGFX applications is doing them in the designer and then adding code on the side. So you can create the look and the feel in the designer, and then you can create sort of the more logic part of your application in code. What else you get is a lot of application templates, we call it, but the support for having TouchGFX applications running on different evaluation boards. So we have quite a long list of evaluation boards from different vendors, and quite a long list of examples that can teach you a lot of stuff, how to do a button, understanding applications, larger demos, so you can see how to do a really large application. So yeah, that's what you get when you download TouchGFX. Yeah, there's a short slide on how the software is actually layered or structured. I'm not going to go into much detail, but today we'll be looking mostly at doing an application. So that's the higher level layer. And then I want to highlight that the TouchGFX application runs on top of the core and can then run on any operating system or no operating system at all, and on any hardware. So this is abstracted, you could say, so you can make TouchGFX run on all these evaluation boards or on your own hardware using an operating system or not. Great. So I think I'll actually go to my desktop out of this slideshow. I hope you can follow along still. Great. So I've installed TouchGFX 4.9.3, and I will just open that and let's see if we can get going doing some real application development. So once you open the application, you're actually greeted with this screen that will help you create a new application. And what is a new application? Well, it consists of two parts. One part is what we call the application template. So that is what makes the UI run on some particular board using some particular drivers or some particular setup. Then there's the UI template. That's the, you could say, how does the UI look? So on the left side are things like drivers, on the right side are things like appearance. But let's try to select the board that we have here today. So I'll go here and I'll find ST Micro, and then I'll scroll through the list to find the 769 Discovery Kit. So that's here. I'll just, since we are learning stuff today, I'll just take a look at the information for this board, and you can read a bit. It's 800 by 480. This application template is using free ARTAs. We might as well have an application template that didn't have an operating system, just using no OS, you could say. There's a bit of description down here stating that it's based on a subset of the Cube F7 driver package version 1.4.0. So it's not the newest version of the Cube drivers, but this application template will help you when you do your own port for your board, so you can change with the correct version you have. Maybe you use another version of the Cube drivers, maybe you're using Cube MX, or maybe you're using lower level drivers, and then you can just base yourself on this application template or one of the others that resembles what you are doing the most. Great, and yeah, a couple of images. So I'm fairly certain that this is the board I have here today. So I'll select this one, and then we can go and look at the UI templates. So here are a lot of UI templates. They are, some of them very simple because they are trying to teach you just one thing. So that's typically what we call an example. So how do I use an animated image? How do I use a scalable image? How do I use radio buttons? So on. Then there are demos. So these are larger applications that will do a lot more and be more complex to actually look at, but they can give you an idea of how to do more complex applications. You might notice these small version numbers, and they are not that important, but it means we are able to update all of these templates as they are online. So what is actually happening once I select a template is that it will get the version stated here, download it, and use that in my application. Great. I don't think we should go into any of these. We'll just do a blank one today, but I would really recommend that you would take a look at all of these examples. One is understanding application structure, where you can learn a lot about the different parts of TouchGFX, but you should take a look at these templates once you have the time. Great. Today we'll just go with the blank UI, since we want to, for educational purposes, you could say we want to build everything bottom up. So now the right board, the right UI template, and then this gives me the ability to choose between 16 and 24-bit, and this of course has a performance impact on the amount of RAM especially I'm going to use, and also the amount of flash I'm going to use. But I'll just go with 16-bit colors because that looks okay to me. The width, the height is given by the dimensions of the board. So let's create this application. I think let's call it something so we can find it. Let's say webinar, place it in this folder and create. So the packages are being downloaded, if not already downloaded, and then combined into an application. So it's What we're looking at now is a combination of the application template and UI template. Great. And now we actually have a running application that I could flash to the board. It's not terribly exciting because it's not doing anything. It's just a black screen. But we have a working application that we can start editing or doing small changes to. I think first off, since I can see in the poll that most of you are quite new to TouchGFX development, I will just go through what it is we are looking on here. So this is TouchGFX Designer, a UI tool that will help you do your UI development. On the top left, we have the structure of your screen. So this screen is very simple. It just has nothing, but we can try adding some structure by adding a widget from the bottom left. So I'll just add a box. Great, and now we can see that my screen has a bit more structure. So that's the left side where you have the structure of your screens. You also have the structure of what we call custom containers. That's where you build custom elements that you want to reuse throughout your application. We're not going into that today, but think of it as building small elements, just like building screens. Today we'll just be building screens. Down here on the left, you also have images, so that's where you could import images that you will use in your application. And I think today I'll actually be using a couple of images. So I have a couple of nice logos that I will import. And now I have these ready for my disposal. Great, that's the left side. The right side is properties. So if I select the box, I get all the properties for this box. I can of course select the box out here on the canvas as well, as I just selected it in the tree. But now I have a lot of properties that I can alter. So I can say, make this another color, make it semi-transparent, change the names. Maybe I want to call this the background. And the reason for choosing reasonable names is that we are actually doing code here. It's just in a nicer way. We are doing visual coding, you could say. Great, but now I have a very, very nice background. And I've gone through most of the interface. I think we need this tab up here. That's interactions. So we'll do some in a minute, but that's where you add dynamicity to your application. So if you want a button to trigger some kind of action, you will go here to the interactions tab. Great. Besides that, we have the texts area, text pane, where you can do all your translations in different languages, create texts, resources, define typography, so everything looks precisely the way you want. Today we'll not be using text, but as you saw Jørn mention earlier, we'll do an entire webinar on doing text the right way. Because text can be quite a large portion of an app when you have it translated to 30-something languages. Great, the last part is the 3 buttons up here. Generate code will take whatever I have built here in the designer and spit out the C++ equivalent. Run simulator will compile that code and run it on the PC. So I can actually run TouchGFX applications on the PC. It's just using, you could say, the operating system is Windows and the hardware abstraction layer is Windows as well. And I can also run target, so I can actually here get my application running directly on my STM32. And in this case, all of this is fully configurable. So if you have your own target, you can also support these buttons. It's done in what is called the TouchGFX file. So that's where you can define how to flash a board. We use ST-Link in this case, and we use GCC as compiler. So the C++ code will be compiled with GCC, cross-compiled, and then flashed using ST-Link. Great. Okay, but let's continue making this application a bit more interesting. So let's add the TouchGFX image and center it nicely here. And then let's make it fade out, I think, and let's go to another screen. So we can call, maybe we should define this screen as the splash screen. That could be a typical scenario in many applications. So it's where we want to start up. And then let's create another screen where we adjust stuff, and that's our settings screen. Great. And now let's start on the splash screen, fade out this logo, and then transition to the settings screen. So I will go to the interactions, as I just mentioned before, and I want to add an interaction here. So interactions are a crucial part of doing applications, but what they ultimately result in is just method calls. So they are just a nice way of writing method calls visually. So one method call is screen entered, and that should trigger this interaction. So when the screen is entered, what should happen? Well, we could fade this, but I think it would be nice to just wait 1 second. So we can wait for, oops, sorry, I need to press numlock here. I'll do like this. We'll wait for 1000 milliseconds, and then we'll do another interaction after that. So when another interaction is done, namely the interaction that we just defined, let's fade TouchGFX to nothing or to completely transparent. And we have a way of defining what kind of easing equation should be used. So we'll just do cubic and say 1 second. And then once that is done, let's then go to the other screen. So another interaction is done, this time interaction 2. Let's change screen to our settings screen, the other one we just defined. And we want to slide to the east. Okay, now we just need to put a little bit of contents on the settings screen so we can actually see something. So let's go here and choose one of the many widgets that are over here. Not every possible widget is over here, but a lot of widgets are, and this area is growing all the time. As we are speaking, we are adding, I think, 4 or 5 widgets for the next version of TouchGFX. But you are, of course, also able to add widgets in code. We'll have a short look at how to do that later, but right here, I just want to select one of these. I want to do the tiled image. So a tiled image will just be repeating the same image again and again all over the area I define. So let's select one of the styles already here. Maybe something like this. And let's fill the entire screen. So a widget as the tiled image widget will be quite efficient in the amount of flash used, because it will just be a tiny image and then it will be repeated again and again, and it's fairly efficient to draw an image using the chromart on the STM32. So yeah, this will save you flash space, but will be very efficient to draw. Great. And on this page, let's just add the ST logo. We can do it like this, so we can use the image widget like this. Go and find our image over here. Great. Let's put it here. Okay, so let's actually try compiling our code using GCC and seeing the fade of the splash screen and the moving to the settings screen. So right now it has generated the code. It's compiling using GCC, and hopefully within a few seconds we have our application, the logo fades and transitions to the settings screen. So quite easy to do this and quite easy to iterate, because I can easily go change a few things in the designer. I want the logo up here. I want the background to be a little bit lighter. And then I can again generate the code, run the simulator, and see how are things looking. And so I can iterate my UI designs or my UI concepts within a few seconds. It was almost hard to see because it looks it looks so much as the yeah. Okay, great. So let's make this application a little bit more interesting. And please feel free to pop in with questions if there are any. I'm eager to answer them, but
yeah, Martin, let me. If you mute, Martin, there's a question coming in. Well, a lot of questions are actually coming in, and this is great. And Jesper is answering most of them. One is actually what inputs Trustee Effects is capable of using. This guy is writing, we are not using touch, we are using physical buttons in order to get inputs and control. Yes. And Martin, you can I think you can answer this one. How TouchGFX works.
Sure. A bit of it is given in the name TouchGFX. We support touch, but we also support any other kind of event. Some events are really easy to propagate. So something like a touch event is built into the system. So we have a method called handle click, handle drag that will be automatically invoked. But we also have a concept called a button controller that you can use if you just need a simple physical button with a limited amount of values, you could say. So that will also give you a handle key press, we call it, handle key event. So that's also very easy to do. So things like physical buttons are very easy to get into your application, into your model or presenter or view. If you have other input, you can also do that. I don't know what you could imagine, but some kind of a non-button, it could be something more complex. It's all just events, which ultimately results in just C++ method calls that you can somehow read out from your hardware and propagate to the correct view or correct presenter or the model. So you could say we support everything. Some things are just supported more out of the box. For instance, on the board I have here, touch is supported out of the box. You don't need to do anything. If you want to add some kind of button to this board using, I don't know, some kind of connector, you will need to do a little bit of code yourself and then propagate that event and handle that event. But it's easy to do, and we have articles describing how to do it. Hopefully that answers the question.
Yeah, this is good, Martin. Just a side note, a lot of questions is coming in. This is great. Jesper is lining them up and answering. We will do all the answering we could do during the webinar. Afterwards, probably some is still unanswered, and this will be done afterwards. So you will be able to receive the answers on all the questions. Okay, Martin, please.
Great. Yes, so let's put a bit of life into this application. It's already fairly lively, but let's actually do something and create a bit of code. So I have an idea of using another widget, a slider, which can be dragged. So this is using touch input as just mentioned. And I want to use this slider to control the value of this image up here. So I'll just rename this image to, let's say, ST logo. And this slider I want to use to adjust the alpha, the transparency of this image. So let's just take a look at the properties of the slider. I can place it, I can style it, I can choose some images. Yeah. Down here I have some values. So that is the values that the slider is actually emitting. Since I will be controlling alpha, which is an 8-bit value in this case, the transparency level, I want to go from minimum 0 to maximum 255. Great. That's my slider. Then I want to connect this slider to this logo. So let's try to do that using an interaction. So the trigger in this case, now I have more triggers available. So the amount of triggers present is, you could say, context dependent or context sensitive. And right now I can choose slider value change. So whenever the slider changes its value, I want to do something. And I cannot really use the fade widget here, even though it seems obvious, because I cannot get the value out of the slider. So what I instead want to do, which gives me quite a bit of flexibility, is to call a virtual function. And let's just say fade ST logo. So whenever the slider has its value changed, let's fade the ST logo. Great. And now I want to implement this virtual function. So let's actually go to the code. Great. So I'll go through the code in a little while, but for now I'll just open it in Visual Studio and actually start coding, and then we can have a look at what is actually present here in my project. This is the webinar project that we created. But I want to find the simulator, Visual Studio solution. So let me open that. And this is one of the IDEs that we support and one of the compilers that we support. So whenever you do changes in the designer, everything is reflected in this solution. And the same applies to IAR and Kyle. Everything is really just plug and play ready. I can take this application and compile it and run it from Visual Studio. So behind the scenes, TouchGFX Designer is doing a lot of updating of project files. All of this is also completely configurable, so, or not even configurable, it's something you can edit any way you like. There's just a few hooks, so you can say, how should my project be updated? You can create a script that updates your, let's say, Atomic True Studio project or whatever IDE you're using. Great. So let's take a look at what has been generated for us. So in the generated folder, oh, this is small, but it doesn't matter. It should be fixed. Okay. For the settings screen, we can see we have a base class here. So this is what is actually being generated by the designer. The designer will generate base classes. And if we take a look down here, we can see we have the image, the ST logo. We have the slider, slider 1. Then we have a callback and some other things. But what is important here is the method we just defined, the fade ST logo method, which it says override and implement this function in settings view. So there's a dependent class on this class, which we can go to. It's down in the GUI folder. the settings view down here, and we can actually override this method to do something. So a user should never change any code in the base classes, but in the real user classes. So if we go to the settings view, we can see that this view extends the base class, the one generated by the designer. And here we can actually implement whatever we want for this method. Great. So in the case of fading the ST logo, let's create an implementation that takes the ST logo and sets the alpha value of this to the value supplied. And we know that this value is between 0 and 255 because we just configured it in the designer. So we can update the logo, and then we can ask TouchGFX to redraw this, or actually to collect this part of the screen as an invalid area. So we collect all the invalid areas and then we redraw those. Great. So let's try building this from within Visual Studio. So now we are using the Microsoft Visual Studio compiler, compiling this project over here, or this project that we are in. And it does all the same things that the GCC compiler, or you could say the make file, is doing normally, creating all assets, converting things, compiling everything. And now we're ready to launch our application. Yeah, it fades out, it moves, and we have our slider, which controls this value. Great. So we actually have done a little bit of code to control the value of this slider. I don't know if you noticed it, but when I start up, let's just do it again. When I start up the application and go to the settings screen, something is a bit wrong. The value down here is 0. This one is fully transparent, so it would be nice to actually do something about that. Let's try to do it. We can use the setup screen method of our settings view. So in the setup screen method, this is a method that is called whenever you go to a view or go to this screen. So if we just say that the ST logo should have the alpha value of the slider in the beginning, something like this. This should take whatever is present in the slider and set that to be the the alpha value of the ST logo. And then again, let's make sure that this will be redrawn. Now I can start debugging again, and this is actually working. So now it's from 0 to 255, and it's correct in the beginning as well. And I said start debugging, and I think that's actually really important, that once you go here to Visual Studio, you get a really nice debugging experience. You have the same in Kyle, of course, but here you can do it on the simulator. You can set breakpoints, examine everything you've done.
Martin, okay. Can I put in a question for you?
Please do.
One here saying, is it possible to have base view and base presenter common for all screens designed in Designer, in TouchGFX Designer? Do you get the question? Is it possible to have base view and base presenter common for all screen designed in TouchGFX Designer?
I think I understand the question. At the moment, no, but it's something that we are working on and something we want to do. So it's something, if you look at some of our older demos before doing the designer, this was the way we would do a common application logic or common appearance, was to create a really common base view that all other views would extend, and the same could be done for a presenter. At the moment, this is not possible in the designer. So there you would have to replicate by using some components that you would then set into each of the different views you have. So think of creating a custom container that has some of the base appearance and base functionality. That would be the way to do it using the designer. Of course, you can also do some kind of hybrid where you alter the code in some way. So take the output from the designer and alter that applying some base classes. It's probably not easy, but it can be done using a script, I would assume. I can say it's something we are working on putting in because we like the functionality as well, doing a common base class. But we have had this question a few times, which also makes it probably a good idea to implement it. But we've also had people saying that once changing to a more compositional way of doing it, applying the same component to all screens, it's really not that bad. So it will be done, but it's not ready.
Okay, good.
That's it?
Yeah.
Okay, great. So where were we? We had a slider changing something on screen. I think I will just move back to my slideshow because what we've seen now is almost everything needed to do UI application development. Of course, you need to know how to do custom containers, do text, do custom widgets, so on. But I think the last thing that we will go through today is doing something that is closer to what all of you will be doing, namely having something coming from a backend system. So I have this slide, application architecture, and this highlights the structure of TouchGFX applications. So we've already seen some of this, namely the views, and we've seen the base views as well. So it's a fairly common way of structuring an application or a pattern way of doing this. So we have view and we have presenter and we have model. The views are what we've seen. They are things like buttons, images, callbacks for when you click a button, stuff like that will reside in the view. The model will have the state of everything in the view, you could say. So if you are showing a temperature on your view, this temperature will reside in the model. The presenter then communicates between these two. So whenever anything happens in the model or anything happens in the view, the presenter will have the logic to inform the model, please do this, the view, please do this. So for instance, someone clicking, I want to increase the room temperature in the view, the presenter will be informed, and the presenter might say, disable the button for a little while, tell the model to increase the room temperature. Then the model will probably tell the backend system, please increase the room temperature. A bit later, the backend system will say the room temperature has been increased. And now the model will tell the presenter, room temperature has increased. And now the presenter can say, okay, then enable that button again and update the current temperature shown on the screen. Something like that. So that's the way all things are structured. All events that go from the backend to the view go through this model view presenter hierarchy. And this also highlights the way that you do integration in a TouchGFX application with your backend system. These arrows are completely up to you how to do these. So we have no restriction on how you can integrate with your existing control system. You just call methods, read temperatures. This could also be sending operating system messages to another task. This is completely up to you what makes sense. Maybe your readouts are very slow or should be sampled at some regular rate, who knows? But you can choose completely what you want here. Great, and we'll have a look at actually doing doing a bit of model view presenter code in just a short while. I'll just show you these application classes also involved. So we just saw, and maybe you already know this, so I'll be quick, that the framework provides some classes, things like the view, the presenter, the MVP application. The generated files are what is generated by the designer. So that's where we create base classes. So for instance, for one particular view, you get this base class. And then you yourself will write the extension of this class with everything you need down here. So you'll create my screen view that extends this base class. For the presenter, we are not doing anything at the moment for generated files. We have the front-end application base and front-end heap base. That is for allocating all the memory needed. TouchGFX, I don't think I've mentioned that yet, but there's no dynamic memory allocation in TouchGFX, which is quite a nice feature when you're doing embedded development. So every part of memory that is needed is calculated here in the front-end heap base, but you can add additional memory down here. And the front-end application base is where all your inter-screen methods are. So things like changing from one screen to another are here. And if you want to have more than the ones generated by the designer, you can create them down here. Great. Okay, so let's go back to the code and do a little bit more development and then ultimately see it running on the board. Okay, but I think this value, the alpha value that we are changing with our slider, it would make sense to actually send this alpha value to the model, and then it can be sent to some kind of backend system. So let's just try sending this value from the view to the model. So here I have the presenter, and then I can say, let's say alpha value change requested, something like that. Oops, I hit some kind of, great. So whenever we change the alpha value, let's tell the presenter, and we'll just create a method here in the presenter. And in our case, we just want to delegate this on to the model. So let's tell the model that we want to change the alpha value like this. And now again, we can create this method in the model. And let's go to that method. And now it might make sense to, in your final application, you would send this value to your backend system probably. But for now, we will just save this in a variable. But here would be a place to propagate this value through a message to an operating system task, something like that. To another task, you could send a message on email or something like that, a mail. Great, but let's just introduce this variable. Great, and let's set it to 0 in the beginning. Doesn't matter, but great. So now information is actually flowing from the view to the model. Great. So let's see that in action. So I'll run the application again, and I will. Yeah, let's just run it.
Martin, we got quite some questions about memory needs and memory allocation. How we do this static dynamic. Just a few words.
Yes. So the way TouchGFX is structured from the bottom up is that there's no newing of anything. Everything is statically allocated. So the same as I did here in the views, and the same that the designer is generating, is that the views are also statically allocated. The box, the image, the slider, everything is just being put as a member variable inside the view. And then we, at compile time, determine what is the largest view, what is the largest presenter, what is the largest transition, so on. And we allocate enough room for that. And then when you change from one view to another, or one screen to another, we will reuse the memory. So going from screen 1 to screen 2, we will, you could say, deallocate that memory that was used by screen 1 and allocate memory for screen 2, but not in a dynamic way. We're actually using placement new. So you will just reuse the memory, but it's statically allocated, and you are sure that you have room enough. The memory needs, well, that is hard to say. In general, what takes up the most memory is your frame buffer, but that might be on your display, so it doesn't need to take up any memory. But then the amount of memory needed for a TouchGFX application is from 10 to 30 to 50 kilobytes, depending on what you're doing. You can go quite low, and you can go as high as you like. Okay. Great. So let me just drag this slider, and then let's put a breakpoint in here, and let me drag it again.
Sorry, Martin, just a side note here, we have 8 minutes.
Yes, I'll try to be done in a couple of minutes. Great, so we actually have a real value here from the view to the model that we could send off to a backend system. I think the going the other way, we can also just try to do that. So let me stop here. So let's say that whenever the model is ticked, and this happens regularly whenever the screen is refreshed. Let's just say if the alpha value is 255, else if the alpha value is 0, and then we'll update the alpha value. So let's just create a stack digint add 1. And let's say add equals -1. So let's just do some kind of simulation coming from the model, but this simulation you would typically read from your real hardware, right? So let's alter the alpha value by adding this small add thing, and then let's propagate that to the current view. So let's create a method in the model listener. So the model listener is the interface that all presenters inherit from, and let's just say alpha value updated and supply this alpha value. And let's create this method in the model listener. And then let's go to our settings presenter and override. So first off, the model listener should just have an empty implementation of this method. Like so. So when the alpha value is updated, we don't want to do anything in the model listener. The model listener is really just the interface. But for the settings presenter, let's say we want to update this ST logo. So in the settings presenter, I'll try to be as quick as possible. Virtual void alpha value updated, like so. And we'll send this on to the view.alpha value updated with the alpha value. Something like this. And then in the view, let's say we are going to use this for actually updating the ST logo. ST logo.setAlpha with the alpha value, and let's invalidate like so. So now, hopefully, let's see it again. The model is ticked very often, 60 times per second. We will go up and down using this adder to change the alpha value. We'll send the message alpha value updated to the presender, and the presender will update the view, and the view, where was that? Here will update the ST logo. So hopefully it will go and do a fade up and down continuously, and then I'm done. Let's see. Apparently not.
Martin, can I put in a poll?
Sure. Please do that, and I will just take a look at it.
Just launch a poll for you all, please. Answer this one. What hardware will you use, or are you already using on your current or coming UI project? Please type in here, and we can have a view on this. And this is coming in. Thank you. It's great to see your activity. I'll wait a little more here. Can follow the percentage. It's close to 90. This is good. Okay. And I think I published it, right? No, sorry. There it is. Okay, and you can see it. Okay, great. Thank you for this.
Okay, and I'm back, I think, and I just corrected the one mistake that I made, so we can call it a day, I think. The model listener, I forgot to write virtual here, meaning that the method that I wanted to override didn't get overridden, but now it does. So adding that virtual and running our application again. Now we have the logo going from 0 to 255, then down again. And this could be a value coming from your hardware and not a value that you are simulating like we just did. So you're good to go, I think. You're ready to do development. Let's just ultimately see it on the board. So we can do that many ways, but I'll just use the designer, and I'll choose run target. So this again will cross compile using GCC, compiling the target code. It takes a little bit longer because there are a lot of driver files to compile. This is only the first time around, but it takes a little bit longer the first time. Once it has compiled all the driver files and all the UI files, we can flash it, and that's being done now automatically, and we're using the ST-Link installed on the PC. So hopefully we can see. Let me just grab the camera.
While Martin is doing this,
we have it over here. So yeah, great. So you can see it's fading in and out. And we can just recycle and see the logo fading. Oh, so I'll just recycle again. Logo fading, going to the other screen, and yeah, things are working, the logo fading in and out. Great.
Okay, great. Thank you, Martin. We are running out of time here, so I'll just try to sum up really quickly from our end. I really hope out there you got the idea of making an application. I will one comment and questions we got during the session was about more integration with hardware, and this we will cover actually in detail in the next in the next webinar coming up June 28. So please have a little bit of patience for this, but also you can have the option to go to the website, the help center, where you have a lot of articles supporting you in actually getting the hardware integration done. One final poll I would like to pull here is actually what kind of what topic you would prefer to we cover in future webinars. Please make a quick selection here, and we will take this in mind moving forward, because this was just the first webinar. We will on a regular basis have both getting started webinars, but also more in-depth technical stuff. Text handling was one that was mentioned during the session. The hardware integration we will look at in the next seminar is actually on STM32 using the same board. And I also recognize that a lot of your questions was related to STM32. Great. Any final comments from Martin and Jesper? Please fill in. Otherwise, from our side, thank you for attending, and hope to see you next time later in June. Thank you.